and welcome to Amomi's Coding Colors Lesson 1, Getting Started. I'm Sean and I will be your guide on this illuminating journey. Let's get going. In this course, we'll be teaching you how to code addressable RGB lights, specifically light strips using the WS2812b LED pixels. If that sounds like gibberish, don't worry, you'll know all about them by the end of this course. But basically, these light strips can be coded so that each pixel is a different color. Therefore, you can code them to create patterns, animations, scroll text, or even images. We'll kick things off with the hardware we'll be using. Don't worry if you don't have any hardware. I'll be introducing free simulators you can use later in the lesson. But let's take a look at the physical stuff first. First up, microcontrollers, the brains of the operation. Technically, this is a development board, and the chip on it is the microcontroller. But these boards are commonly referred to as microcontrollers, so we'll stick with that. Microcontroller receives signals from input devices such as sensors, buttons, and dials, and instructs output devices like motors, buzzers, and lights. The behavior is determined by the code uploaded to the microcontroller. There are many different types of microcontrollers that you can use to follow along with this lesson, but I'll be using the Amomi Uno. This is our version of the popular Arduino Uno R3. Functionally, these two boards are identical, but the Amomi Uno was designed to withstand more power. Therefore, you can control more pixels without needing an external power supply. Other than wires, the only other thing you need is an addressable RGB strip, like this one. To get an understanding of what addressable RGB strips are, we'll look at a regular RGB LED and talk about some of the issues. A regular RGB LED is basically three LEDs built as one, either with their cathodes or anodes connected together. You simply control the amount of power going through each color to create other colors. I have one here set up to demonstrate. Theoretically, as I turn these dials controlling how much power goes through the red, green, and blue filament, I can create any color. This works fine, but I need 3 signal lines for just one RGB LED. Now, if I wanted to control 1,000 LEDs, I would need 3,000 signal lines. This is obviously unrealistic. That's where addressable LEDs come in. Each pixel also has an RGB filament, but the way they are controlled is different. These LEDs are connected in series, and each pixel has a microchip of its own. Information is sent from one pixel to the next, meaning that you can control a huge number of pixels using only one signal line. This is a game changer and is what we are going to learn throughout this course. Let's take a look at the software you'll be using. We'll start with the Arduino IDE. This is the coding platform where we will be writing all of our code. There's a link to it below this video. So on this page, scroll down to the links and downloads section and click on the first link here. This will take you to the downloads page on the Arduino website, and you can select the version that's right for your particular computer. For mine, for example, is a Windows computer, so I'll select this one on the top. After you have downloaded the IDE, open it up and you'll see something like this. In the middle of the IDE, this is where we write the code, and there are various tools and pieces of information around the edges. We'll be covering some of these as and when we use them. The only part we care about for now is this thing over here that looks like a stack of books. When we click on it, it opens the library manager. A coding library is basically pre-written code that you can access, making complex tasks much easier. We'll be using the FastLED library to help us code our pixels. From the library manager, type in FastLED. And the first one that comes up will be the FastLED library by Daniel Garcia. In my case, it says remove. That's because I already have it installed. For you, it will probably say install. Click the install button and you should have the library ready to use. To check whether or not it has worked, you can go to File, Examples, and scroll down to where you should be able to find the library FastLED. In my case, I have a ton of other libraries. That's just because I've downloaded them on other occasions. You won't have as many of this, but as long as you can find FastLED, you're all good. To close the library manager, you simply click on the icon again. Done. Next, let's take a quick look at the simulator that we'll be using. There is a link to it on the web page. Even if you have the hardware, I still recommend trying out the simulator. It's a useful piece of software and allows you to try out ideas on the go. So again, from the lessons page, scroll down to the links and downloads and click the second link here called WokWi. That's the name of the simulator we will be using, and it takes you to this window. Right away, you could start simulating, but I advise that you sign up If you sign up, you're able to save your projects. If you don't, you aren't. Once you're signed into your account, head over to the library manager, which is this link up the top, hit the plus button and download the FastLED library. I'll click on it. And that's it. You're ready to start simulating. Now that we're acquainted with the software, let's build the circuit. We'll first build the circuit using the online simulator because that makes it very clear where the wires go. And then we'll move on to the real thing. In the hardware section of the simulator, hit the plus button and type in WS2812, and that will bring up these two options. Select the NeoPixel compatible LED ring, and this will open up. This is basically the same as what we're going to use here with the hardware. It's an LED strip, but it's set as a circle rather than a straight line. This one has 16 pixels, but the hardware version that I'm using only has 8. This doesn't matter, and you'll see soon in the code that a small change will make it work for either. Before we start connecting the wires, we'll take a quick look at the microcontroller. If we zoom in here, we can see the various parts of the Arduino Uno. We're not going to go through all of them. We'll just talk about the parts that we care about for this particular project. Across the top here, we've got different pins, which are the I/O pins, which stands for input and output. These pins can be used for sending or receiving digital signals. For example, you could connect buttons or sensors and send information from these sensors to the microcontroller, or you can send information out from these pins to output devices like buzzers, or in our case, LEDs. We also care about the power section down here. We can think of this as being like a battery, with the 5 volt being the positive terminal of a battery, of a 5 volt battery, and the GND, which stands for ground, as being the negative terminal. If we look at the pins here with the LED pixels, we can see that we have 4 of them. The rightmost one, that is called D out, stands for digital out. This would only be used if we are using more than one of these rings, but we're only using one, so we can ignore this last pin here. The other pins are the ones that we'll be using. We'll start by looking at this one, DIN. Now, DIN stands for digital in. This is where we're going to receive information in from the Arduino. So the Arduino will send a signal out and it goes into the DIN pin of the ring here. So I'm going to connect this one to digital pin 9. You don't have to use digital pin 9, but that's just my go-to when I'm using pixels like this. I always use pin 9, so it's just logged in my memory that way. You don't have to use 9. You could choose 7, 6, 5, whatever else, doesn't matter. However, just a quick note, we usually avoid pins 1 and 0 because they're used for data transfer between your computer and the Arduino. Next up, we can connect the VCC pin to 5 volts. And we can connect ground from the Arduino to ground on the LED ring. Okay, that is done and we could start coding it now. But there's one thing I want you to note. This one has 16 pixels. The one that we are using is 8 pixels. This is a relatively low amount of pixels, so it should be fine to power it directly from the microcontroller. However, if you are going to try and power a lot of pixels, let's say a full strip around your bedroom, it would be advisable to use an external power source. That's because if you try to draw too much power from a microcontroller, it will shut itself down. The Amomi Uno that I'm using can handle 3 to 4 times more pixels than the regular Arduino Uno R3. And it has USB-C, which is also better at power handling. But for controlling the 8 or 16 pixels that we're using, both of them will work exactly the same. Now that we've wired up the virtual version, let's move on and wire up the real one. So we'll need our microcontroller, our LED strip, and some jumper wires. The jumper wires that I will be using have female headers on one end and male headers on the other. I'm only concerned with using one strip, so I only care about the input side, which means information is going to be input into this from the microcontroller. So we just care about these 3 pins. We have a 5 volt pin, a ground pin, and a signal pin. I will just note which color is connected to which pin. I've got red going to 5 volts, I've got orange going to signal, and yellow going to ground. I'll connect 5 volts to 5 volts, ground to ground, and the signal pin to pin number 9, just like on our simulated version. The only other thing you need is a USB wire. You'll have probably gotten one with your microcontroller when you bought it. In the case of the Amomi Uno, it's a USB-C wire, which is ideal because these can handle more power than a regular USB. Okay, now we're all set up. Let's write our first code. We'll move on over to the Arduino IDE to do that. Before we do any real coding, let's look at the basic setup of code written on the Arduino IDE. We can think of our code as having 3 sections. The top section you have to make yourself by putting the cursor in front of the setup and hitting return a few times. So I like to think of it as being 3 sections, 1, 2, and 3. The top section we'll call the declaration section, is where we include our libraries, we declare certain variables and such things like that. In the setup, this is where we put the code that has just run once. For example, when you turn on your iPhone and the icon comes on, and while it's setting up all of the various things that need to be set up, we could think of that as being like the setup code. The main loop, this is the code that runs repeatedly as long as the microcontroller is turned on. This is the main code that controls how your project behaves. All of the coding that we do in this lesson will be done here. We'll be using a template that I have written for you for the declaration and setup sections, but we will talk about what the various lines of code are in the template. So let's go and open up the template. On the lessons page, if you go down to the links and downloads, you will see a lesson code link. Click on that and download the zip file. Extract the zip file and go to the lesson code folder, and you should find a CC basic template. Double click on that and it will open up. Okay, this is the template that we'll be using as a starter for pretty much every code that we do in this course. So it's a good idea to always go to File and Save As, so you don't save over the original. So we always keep the original untouched, and then any changes we make is to the new file that you've made when you hit Save As. So let's go File, Save As, and let's call this traffic_lights. You can't leave any spaces, so I've used the underscore, no spaces. Hit save. Okay, so as you can see, like we mentioned, we have some code in the declaration section. We have some in the setup, but the loop is empty. That's where we're going to be writing the code. But let's go through the code that has been included for you. At the top, we have the FastLED library. Anytime you want to use library or access this code that is pre-written, you must include the library, and this is how you do it. Next up, we need to define how many LEDs we've got. So in our simulated version, we're using 16 LEDs, so we'll need to change that to 16. In this version, I'm just using 8 LEDs, so I'll leave that as 8. The data pin is the pin that you are connecting your LED strip to on the microcontroller. In our case, we're using pin 9, so I'll leave that as a 9. The next line of code is a very important one, so we'll spend a little bit more time talking about it. This is an array. An array is basically a list where you can save information to. In our case, we're saying that we have a CRGB array called LEDs, that's its name, and this is its size. So num LEDs, how big is num LEDs? Num LEDs in our case equals 8. So that means this array, you can save 8 pieces of information to this array. You can probably guess what this information is. The color of each pixel. So we can think of the array as having 8 different spaces where we can save information to. Let's just draw it out for now. So think of it like this. So right now we've got 8 blank spots of information. We need to fill in what colors we want. So we can think of this as being the first pixel, second, third, fourth, and so on. we need to, in our code down here, we need to occupy this array with information about what color we want the pixels to be. After we've set up the colors in the array, we send another line of code which sends that information to the pixels and they shine that color. That's all we're doing. One thing that's useful to know is that we don't look at this as being number 1. We look at it as number 0. It is 0 index. So we've got position 0, 1, 2, 3, 4, 5, 6, and 7. If we want to control the last LED, this one here, we will be looking at pixel number 7. If we want to control the first LED, this one here, we will be looking at pixel number 0. So 0 to 7, that's 8 pixels. All right, let's delete this. This was just a visual representation of what I'm talking about. There we go. All right, next up, this is initializing the library, sending information to the library that it needs, information such as the chipset we are using, the data pin we are using, the name of the array, and how many LEDs there are. And then we need to initialize the brightness. We need to say how bright do we want it to be. And that's a range from 0 to 255. I've set mine to 50, which is bright enough for us to see, but not so bright that it's going to hurt our eyes. 50 should be fine for your project too, and then go up from there. And just keep in mind, the higher this number is, the more power that you're drawing from your microcontroller. All right. So like I mentioned before, all we're doing in our loop is occupying this array with different information of colors that each pixel is. So let's just start by making the first pixel, pixel 0, let's make it red. The easiest way to do that is to, first of all, show which pixel you care about. So it's in the array LEDs, square bracket, 0, pixel number 0. And then we say it equals, when we use a single equals, we are assigning a value, equals C RGB colon, and then type in the color. So the first one is going to be red. As simple as that. If I were to upload this code now, this value, this color red, CRGB red, will be assigned to the first position in our array over here. But all that's doing is assigning it to the array. We need to send this information to the hardware. And the way we do that is with this command, which is FastLED. And it is case sensitive, so it does need to be a capital F and capital LED. FastLED dot show with brackets or parentheses at the end. In England, we call them brackets. I know in America, these would be parentheses. So I'll go with that. And we're ready to upload. Before we upload, we need to make sure that the Arduino IDE is connected to your board. So let's do that. We hit this drop down menu here. And in my case, you can see we've got 1, 2, 3 COM ports that we could select from. We've got these different ones. There is COM4, COM6, and COM14. One of them is probably my microphone. One of them is probably my mouse. And the other one will be the Uno. But we don't know which is which. The best way to figure it out is to keep the drop down menu open and unplug your microcontroller, and the one that disappears is obviously the one that is being used for your microcontroller. Push it back in. When it reappears, now it says COM18 because I put it in a different slot this time. Click on it and then select the board. Type in Uno and select the Arduino Uno. In my case, I'm selecting the Arduino Uno, even though I'm using the Momi Uno, because like I said, this is just a version of the Arduino Uno. And then hit OK. Upload the code. And if everything's done correctly, LED 0 will glow red. As you can see, pixel 0 is glowing red, but let's carry on with our traffic light. We need the next two lights to turn on too. As you can see, when we uploaded the code, this thing popped up, and this gives us some information about the upload, such as how much of the memory is being used up. And also if there's an error with the code, this information will be displayed down here. I'll hit upload again so we can focus on down here. We get this thing that says compiling, and then done compiling, and eventually done uploading. If it says done uploading, that means it's been successful. If yours is not successful, try to read through what the error message is and see if you can spot it. See, maybe you missed a semicolon is a common error. So make sure there's always a semicolon at the end of your lines. Try to copy mine exactly. Okay, excellent. Let's move on. So if we can just put our cursor in front of the FastLED.show function, press return a couple of times to create some space, and then let's copy this line, go below, paste it again. Then the next LED is going to be LED 1, and the one after that is LED 2. This one is going to be yellow, and the last one is going to be green. So it'll be red, yellow, green. If any of you are screaming at your computer that it should be amber, not yellow, I am aware of that, but amber is not included in the FastLED library. So if you do want to use amber, we can update that in the next lesson when we learn about different color protocols. So don't worry. All right, here we go. So you can think about it. You could have put FastLED.show after each one, but it's not necessary at all because, like we said, all we're doing in this part of the code is occupying our array with the information we need. So we're saying that position 0 is red, position 1 is yellow, position 2 is green. And then once we're happy that we've put the information in that we want to put in, we can say FastLED.show, and it should show the colors that we want. Let's see if it works. Hit the upload button and wait. And you can see now we have our red, yellow, and green. That's basically it. We could leave it there, but why not make it flash? Let's have a flashing yellow light, and let's see how we would do that. So this, we know that this works already to show what we want. Now, how can we turn off this middle one? Let's just make the middle one flash. So to turn off the middle one, well, which color can you not glow from a pixel? The color black. So if we change this yellow to black, it should turn it off. However, this loop loops many thousands of times per second. So if we're turning it to yellow and black thousands and thousands of times, it's not going to work properly. We need to slow the code down. Now, one way to do this is using the delay function. So we type delay, then in the parentheses, we write how long we want it to delay in milliseconds. So let's say we want it to flash at half a second intervals, half a second on, half a second off. Type in 500 milliseconds, which is half a second. So we basically show this delay, and then we change this one, which was yellow, to black, and we need to show it, and then hit delay again for 500 milliseconds, and then that should work nicely. It should be showing these colors, and then changing just the LED to black, just the yellow one to black, showing that for half a second, and then it'll loop back around and do this continuously. Let's upload that, see how it looks. And as you can see, that's working nicely. We've got the yellow LED flashing. If you want, you can play around with the code and try doing much more complex patterns with the red flashing, the green, the yellow, or whatever you like. Now we can transfer the code over to the simulator and see if it works there too. So next up, you need to copy it all. So I'll hit Control and A and then Control and C to copy it all. You could also highlight it manually by dragging over it, then right-clicking and hitting copy. Same thing. Then go back to our simulator. Highlight all of this code and delete it. Then Control and V, or right-click and paste. Allow. And you can see your code is here. One thing that's different is the number of LEDs for this one is 16. So we'll change this to 16. And then we will hit play and start the simulation. And you can see it's working, but it's very dark. So you can see that the simulator, the brightness is not quite the same as the actual one. So all we need to do is adjust the brightness, change it up. We might as well go full brightness, 255, and then restart the simulation and see what happens. And you can see we have our lights flashing there with the amber flashing on and off, or the yellow flashing on and off. So you can see that works just fine. And it's a great way for you to test your projects before doing on actual hardware. You could do it on the go as well without having to bring anything with you. That's pretty useful. All right, that concludes lesson 1. Feel free to play around with your code and try out different ideas before moving on to the next lesson. There's a link to the Coding Colors Facebook group below. I strongly advise everyone join this group, as it's a great place for you to share your progress if you wish, ask for help from myself and fellow students, and where I can share updates with you about changes in the course or any other information. In the next lesson, we'll be looking at color protocols and building on top of the coding skills you've already learned. I hope you enjoyed the first lesson, and I'll see you in the next. Bye.